notice, and this is the typical copyright. 2018 to 2027 syllabus, CSEC, math. Just a reminder that the syllabus has 9 sections, and this is a little reminder again on the format of the exam. Recall that a formula sheet will be provided for all papers. And of course, a silent electronic non-programmable calculator will be permitted in papers 2 and 3 only, not in paper 1, which means that you will need to know the times tables if you hope to pass this exam. I am repeating that this is extremely crucial. You need to know the times tables. Schedule of videos. I will try to get all 32 videos completed from section 1 in September 2024, that is this month. And then next month, the 13 to 15 videos from section 2 and so on, so that by May 2025, the complete syllabus will be done. As I said, section 1, I have subdivided into 32 videos, and all of those videos will be made available in their entirety on YouTube. Just a reminder that this section forms the foundation of the rest of the syllabus. So far, we have covered video 1, sets of numbers, video 2, types of numbers, video 3, factors and multiples, video 4, number sequence. And now we are at video 5, which is objective 2 in section 1, powers of real numbers. Of course, we still have to go to video 32 for this section. So objective 2 in section 1 says that students should be able to compute powers of real numbers of the form x to the a power, where a is a member of q, and so we will be dealing with squares, square roots, cubes, cube roots, and so on. Compute powers of real numbers of the form x to the a power. Note that a is any member of q. Just to remind ourselves what q is, q here includes all rational numbers, that would be fractions that are terminating and recurring, plus the integers, whole numbers, and of course, the natural numbers. So a could be anything from q. But note also that x could be anything from r, which is real numbers. So x could also be irrational numbers. So what are we going to look at? We will look at things like these. 5 to the second power, what is that? 9 to the third power, 2 to the 10th power, 6 to the 4th power. Now, these are very easy. Then we will look at negative 3 to the negative 2 power, or 5 to the negative 3rd power, or to the negative 8th power. These are a little more difficult than those up there, and they will progressively get harder. Then we look at 16 to the half power, or 64 to the 1/5 power, or this number here to the 1/7 power. Then we will look at a whole number here to a fractional index here, but the numerator of the index is not 1 as we had up here. So these that you see here on the left are fairly easy. Then they get a little more complicated, like 4 to the negative 3 second power, or 8 to the negative 2/3 power, and then it gets even more difficult, 3/4 to the negative 3/2 power. So we will be looking at these in this objective. Before we go, let's make sure we understand what we are talking about. If you see 5 to the 4th power, what is that? That really means 5 multiplied by 5 multiplied by 5 multiplied by 5. This 5 here is called the base, and that 4 there is called the index. The base multiplies itself as many times as its index. Note, this is not 5 multiplied by 4. It is 5 multiplied by itself 4 times. So let's look at the very first example, extremely simple. 5 to the 2nd power. That means 5 multiplied by itself twice. So 5 by 5, and that will give us 25. 9 to the 3rd power. That is 9 multiplied by itself 3 times, not 9 multiplied by 3. So 9 multiplied by 9 multiplied by 9, which would give us 729. 6 to the 4th power, that is 6 multiplied by itself 4 times, which will give us this. 2 to the 10th power, that is 2 multiplied by itself 10 times, as we see here, which will give us 1024. Now, 5 to the 0 power is 1. 9 to the 0 power is 1. And b to the 0 power is 1. That is to say, anything with a 0 index equals 1 except 0 itself, which is undefined. If you find this video useful and or interesting, please like and share. Like and share. You may even subscribe to the channel. It doesn't cost you anything, and it means a lot to me. So let's move on with negative indices. Now, what that means is that the numbers represent a vulgar fraction with 1 as the numerator, and these indices that now become positive goes down as a denominator. So if you have x to the negative a power, that becomes 1 over x to the positive a power. So let's look at some examples. 5 to the negative 3rd power becomes 1 over 5 to the 3rd power. And now you could work out this piece below here, 5 times 5 times 5. Remember the 1 at the top there. So it's now 1 over 125. Another example, 2 to the negative 8 power. That is to say, 1 over 2 to the 8th power. Again, you can easily work this out. We know how to do that. But remember, that will be 1 over that. And if you have negative 3 to the negative 2nd power, remember, this 1 over the rest of the stuff without this negative. So it's 1 over negative 3 to the 2nd power, which is 1 over 9. Now, if the index is a fraction with 1 as the numerator, then we use the denominator as the root of the given base. So 16 to the half power, this numerator of the index is 1, but this is another number. We will find this root of this number. So that will be the square root of 16, and we get 4. Another example, 64 to the 1/5 power, we will find the 5th root of 64. The 5th root of 64, and we get 2. Then if you have this number to the 1/7 power, you will find the 7th root of this number, which is this. You put that in your calculator and you get 4. Now, if the index is a fraction and 1 is not the numerator of that fraction, it's a little more complicated. So we will use the denominator as the root, as we just did, but now we will use the numerator as the power. So if you have 4 to the 3 second power, you will find the square root of 4, and the answer you then get, you will carry it to the 3rd power. So the square root of 4, which is 2, and we then carry that 2 to the 3rd power, and we get 8. 8 to the 2/3 power. We will find the cube root of 8, and the answer we get, we will then carry it to the 2nd power. So, well, in this case, we actually find the 2nd power of 8 first, and then we get the cube root. So the 2nd power of 8 would give you 64, 8, 64. And then when we find the cube root of that, we get 4. So at this point, you may be wondering, which one do we do first? Do we do the root first and then the power? Or do we do the power first and then the root? Actually, it doesn't matter which one is done first, provided you do both of them. Now, 9 to the 4/5 power. So you will find the 5th root of 9, and the answer you get, you will carry it to the 4th power, or you can find the 4th power of 9, and the answer you get, you then find the 5th root. In this case, we actually found the 4th power of 9 first, we get this, and then we find the 5th root, and we get that. Now, as I pointed out just now, it doesn't matter which order you follow. So here are some examples, computer generated. We are looking at 6 to the 2/3 power, 6 to the 2/3 power. Now, if you find the power first, you get the square of 6, which would give you 36. And then you find the cube root of 36, and you get that. Now, if you find the root first, you find the cube root of 6 first, you get this, and then you find the power, the square, and you get this. Notice that these two numbers here are the same. And that follows for the rest of these examples. For anybody who wants to know what formula was used, here are the formulae. As I said, it doesn't matter which you do first, provided this here is the root and that there is the power. 3.3, 3.3, 4.6, 4.6, and so on. Okay, let's move on. So we did that, and this, and this, and that. Those were already done. Now let's move on to the two hardest types, which would be 4 to the negative 3/2, that format. And then after that, we are going to do a fraction down here. So the base is a fraction, and the index is a negative fraction as well. So 4 to the negative 3/2 power, and 8 to the negative 2/3 power, and 9 to the negative 4/5 power. What that negative means is that everything here goes under 1. So if we have 4 to the negative 3/2, we will remove that negative from there, put 1 there, and everything else under it. So it actually is the inverse of what you see here. So 4 to the negative 3/2 power becomes 1 over 4 to the positive 3/2 power. Of course, you work out the below piece. the square root of 4, and the answer you get, you cube that, which would give us 8. 1 over 8 will give us this answer. The same thing goes for this whole number here, 8 to the negative 2/3 power. That would be 1 over 8 to the positive 2/3 power. And then you work this piece out here, which would be the cube root of 8 to the power of 2. You get a quarter, which works out to be 0.25. Now, this one here, you can work that out for yourself. It will be 1 over 9 to the 4/5 power. Well, you would find the 5th root of 9, and then find the 4th power of that, and inverse it. Now, for the most difficult type of question, 3/4. Now, that is a vulgar fraction. It could also be a rational fraction. Well, as it is, it's a rational fraction. It could also be an irrational fraction. And the index is -3 seconds. That is a similar example, and this is another similar example. So let's work this first one. 3/4 to the -3 power. What you do is that you invert that and you remove this negative. So 3/4 to the -3 power becomes 4/3 to the 3 power. This doesn't change. This is inverted. And so we take 4/3, we find the square root of that, and whatever we get, we carry that to the 3rd power, and we will get this. 5/8 to the -2/3, we invert the 5/8, remove that negative, and so we get 8/5 to the same 2/3 power. You work out what 8/5 is. You can then square that and then find the cube root of whatever you get, or you could go the other way around, and your answer is 1.37. And lastly, 5/4 to the -4/5. You invert this, and in that way, you get rid of that negative there. So you get 4/5 to the 4/5 power. So you work this piece out here, 4/5, you get 0.8. Then you could either find the 4th power of 8, and the answer you get, you then find the 5th root of that, or you could go the other way around, find the 5th root of 8, and the answer you get, you then carry it to the 4th power. Either way, here, in this case, we are actually finding the 4th power first, and then the 5th root, and we get 0.84. So this objective, compute powers of real numbers in the form x to the a power, where a is a member of rational numbers. And we're supposed to find square, square root, cube, cube roots, and so on. So we just did that. And that brings us to the end of objective 2 in section 1. So we are on our way.